Our previous programs have already introduced some basic arithmetic operators, such as additions or multiplications, as part of expressions. We've used these expressions on the right-hand side of assignments, or we've passed them directly as a function argument, for example, in the print function. Now I'd like to expand our possibilities with additional types of operations supported by Python expressions. The following list includes the most relevant built-in arithmetic operators. We have the plus operator for additions, the plus operator for string concatenation, the minus operator for subtractions, the minus operator for arithmetic negation, the true division operator, the floor division operator, the modulo operator, the multiplication operator, and the exponentiation operator. Let me say a few words about each operator presented in this list. The addition operator, as well as most other operators presented before, can operate on variables of at least two data types, int and float. If the operands on both sides of the plus symbol are of type int, the result is also an int, whereas if at least one of the operands is of type float, the result becomes a float. This rule is intended to accommodate for the data type requiring the most precision. Note that here, when I say the word value, I'm referring to either a variable or a constant. It doesn't matter, both have a data type associated with them. But the plus symbol can also serve a different purpose, as we have studied before. When both of its operands are of type str, again variables, constants, or a mix thereof, it acts as a string concatenation operator. The result of a concatenation is a string prefixed with the first operand and suffixed with the second. The minus symbol can also serve a double purpose. When used as a binary operator, that is, when surrounded by two operands, one on each side, it acts as a subtraction operator. Again, this operator accepts ints or floats, and the type of the result varies accordingly. The second application of the minus symbol is as an arithmetic negation. Python interprets it as such when used as a unary operator, meaning that it is only affected by one operand on its right. Here's an example where the value of variable x is negated and assigned into variable y. Next, the true division operator is represented by the / symbol. It's called true division because the result contains an exact or near exact representation of a division operation, always given as a floating point value, and regardless of the type of its input operands. For example, dividing two integer variables containing values 5 and 2 respectively yields a floating point result equal to 2.5. This behavior is in contrast to the floor division operator, represented by a double /. If its input operands are integers, this operator yields also an integer as a result, where the fractional part of the quotient is simply dropped. Dividing 7 by 2 with a double / provides a result set to 3. Related to the floor division is the modulo operation, represented by the % symbol in Python. The modulo operator calculates the remainder of a division. You can think of the remainder as the leftover after dividing one integer by another using a floor division. For example, dividing 14 by 5 with a floor division yields 2. The integer that, when divided by 5, gives us exactly 2 as a result is 10, and the leftover, or remainder, is 4, calculated as the difference between 14 and 10. 14 modulo 5 is then 4. Next, the multiplication is represented by the star operator, as we've seen in previous lessons. Its input operands can be integers or floats, and the type of the result is deduced by Python accordingly. Finally, a double star operator represents an exponentiation. In these examples, you can see how to leverage this operator to calculate the second, third, and fourth powers of 3. Most arithmetic operators offer an alternative syntax that I'd like to introduce here as well. It is rather common to find situations where the result of a binary operation, one that takes two input operands, needs to be saved in the same variable used as the first operand. In these situations, we may use a shorthand notation based on what we call in-place operators. For example, think of an integer variable I whose value you'd like to increment. This could be done with statement I equal I plus 1, using a construct you're already familiar with. Or instead, you could use an in-place operator by writing I plus equal 1. This notation can be utilized for other operators presented earlier as well. So for example, x minus equal 5 is the same as x equal x minus 5. X times equal 10 is the same as x equal x times 10. And a / equal b is the same as a equal a / b. If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you, and happy coding!